So some of the information in here is going to be review, but value types and reference types are really important, and that is why we are taking another look at them. So for the review information, I am going to go through it rather quickly. We're going to focus more on what is new, because there are a couple new things in here. Value types are the data that is stored in a part of memory called the stack. So these are your primitive values, bool, byte, decimal, int, okay, kind of the ones that we use most often. And the way that it works is you declare your variable, you set a value in it, and the memory location stores the value. Okay, and a primitive is a value type. Okay, value types are used to build more complex data types like lists and arrays. In C#, value types are objects. Pretty much everything is an object in C#. And that is why if we create an integer, give it a name, we can actually use that name to call methods like toString, which would convert our number into a string. Okay, so technically they are objects. Reference types. So a reference type stores data a little different than a value type. A reference type uses a part of memory called the heap. And the way it stores data is the variable points to a location in memory. That location in memory basically refers you to another location where the data is actually stored. Okay. And so that is why it's called a reference type. Okay. And so that is the difference. And it does take a little longer to retrieve, obviously, reference types, because when you go to the memory address, it actually then has to jump to another address to get to the data. Okay. And so strings and arrays, classes, delegates, which we haven't covered yet, those are all reference types. We talked a little bit about null values when we talked about classes. Reference variables can be assigned a value of null, but value types cannot. So you cannot take an integer and assign it to null. Okay, but you can assign an array null, and it'll allow that. So a reference variable can be assigned null, but a value cannot. Now, if you declare a variable that may not contain data, if you use the question operator, then, and that's called a nullable operator, it will allow you to set the value to null. So there's an exception. So you can say for a data type, let's say you can have integer. And if you follow it with the question mark, that means that it may not have data. Okay, and then you can have your variable name and you can set it to null. It will allow that. Okay, that is the only exception. Another way of coding the same thing would be to say nullable, followed by the data type, int, and then the name, and then you can also set it to null. And what you can't do is say int number equals null. That will give you an error. Okay, now, why should you ever do this? Honestly, I can't really think of a reason why I would do this. I have seen it in MVC applications, which we cover in the 218 class. But But normally if it's a number and I'm initializing, I would set it to 0 instead of null. If you do set it to null, then you have to use get value or default. You have to use that method to retrieve the value. Null values do default to 0. So if you use get value or default and you retrieve a 0, that does indicate that you have a null value. So how does this look? So here, if we say nullable and equals null, so this is a null data type. Okay, and then if we were to use that variable n to call get value or default, then it's going to return a 0 because it's null. Here, we've got the question mark, which allows us to use integer. Okay, and 1 for number 1, we set that to null. And then we use n1 to call get value or default. That is also going to retrieve a 0 because it's an integer and it's set to null. Okay. This one. Well, now we've got a variable n2, and we said it might be null, but we actually put a value in it. So when we use get value or default, what does it display? Well, it displays the value that we set. And the same with nullable. Here, if we use nullable n3 and we set it to 100, what does it display? It displays the number that we set it to. Okay, and what I have seen quite a bit is this little syntax here with the question mark. Okay, that is why I included it, just so that you guys could start to get familiar with it. So there are a couple other operators that we really haven't used yet. One is called is, and the other one is as. And basically, one of them checks what kind of object we have, and then the other one actually does a typecast. So first we're going to take a look at is, and this one actually checks to see what we have. So here you can see I've got an empty class, 2 empty classes. Okay? There's nothing there. Okay, and then down here, I create a student and a teacher object, and they're empty. There's nothing there. But because I said new student and new teacher, it is going to think, that this is a student object and this is a teacher object. And then you can see that I've got a variable, an integer variable that I set to 0. And then I am going to test each one of these. Okay, so here I'm writing out a heading, data being tested equals, and I'm just taking this object and converting it to a string so we can print it out. Okay, so that's what I'm doing with each one of those. And then I am calling this test class method. Okay, and I'm passing it my object. So it's going to come up here. And while it's in this method, we're going to refer to the object as O. So first I'm passing it a student. And here it's saying, this is where it's using that is operator. If O is student, well, O is a student, even though it's empty, still is a student. It's going to write this to the console. Okay. Then we call test class and pass it to T. And so now it comes in. It's the letter O. If O is student, well, it's not. Else if O is teacher, it is. So it's going to write this to the console. Okay, and then for the last one, we're passing it I. So it comes in, it's got I now, not a student, not a teacher, and then it prints that to the console. Okay, so you can kind of see how that looks when it runs. So that is what the is does. It basically checks to see if the object is, what you're checking. So is the object part of this class? Then we have as. What as does is it actually performs a conversion, and it only does it between compatible types. So it's kind of the same thing. We've got the empty student class, we've got the empty teacher class, and then we're actually going to create a little array of objects here. And the first object, we set it to the student. The second object we set to teacher. The third object we set to the string student. And the fourth one we set to the string teacher. And then we've got this little loop where we're going to take a look at each one of these. So what it does here is it converts whatever is in my object to a string. And we store that string here. Okay, and then we are checking to see if it's null. If it's null, then it couldn't do the conversion, right? It was not a compatible type. Otherwise, if it's not null, we say that it is compatible. Okay, and then we have a little phrase that we write out. And so it goes through each one of these. And I think I will run this for you guys. All right, so we're going to run this. So the first one, if we remember, was an object. It was actually a student object. And it says it cannot be converted to a string, okay? Because that's the conversion that we were trying to do, right? We were taking the object and we were trying to convert it to a string. The second one also could not be converted. However, you'll notice the third and the fourth one are strings and they were compatible. Okay, so that is how as works. You have a data type that you're trying to convert into something else. Okay, and if it can't do it, it comes back with null, otherwise it does the conversion. So back to the stack and the heap. Value types are stored in the stack. Reference types are stored in the heap. And the names actually come from the way runtime manages memory. So stack, you can kind of conceptualize this as boxes that are stacked neatly on top of each other. So when a method is called, each parameter is put into a little box and it's added to the top of the stack. Every single local variable is also assigned a box, and the box is put on the top of the stack. When a method finishes, then the box is removed. Okay, so you are adding boxes to the stack and you're removing boxes from the stack. Very organized. Heap is like a messy room. There's boxes everywhere. So each box has a label indicating whether or not it's in use. And when you create an object, it actually looks for an empty box. And then if it finds an empty box, it actually allows the object to use the empty box. So it stores a reference to that box, so it knows the location of the box. Okay, so that's kind of the difference between the two. Let's see. And the stack, the memory in the stack is considered temporary. It is a little faster area of memory than the heap. And that's all mainly because of what they put in there. In the heap, remember, you have to go to a memory address and then you have to jump to another one. In the stack, you don't. Okay. So for the heap, the variables are going to have the value for the entire program. It is going to take a little longer to retrieve the values. And there really isn't a limitation as far as size. So lists, array list, and some of the dynamic types that can grow, and we can actually put additional data into them, they're always put in the heap, okay? Because there's not that size limitation on the heap. When to use the heap versus the stack? Well, the program pretty much is going to determine which one to use based on the data types that the variables have. And assigning value types and reference types to other variables or objects. I believe we have looked at this. Oh, this is new. Nope, we have not looked at this. Okay, so what this is talking about is that if you have a value type and you assign a variable to another, it makes a copy. So here I've got number 1. I put a 10 in there, and I put number 1 into number 2. So I've got number 1 and number 2. Each one is storing a 10, and they are separate. They are two different memory locations. Okay. And that is the key for value types. If you copy them, you're going to have more than one value in they're going to be in different memory locations. And that means that if I have something like this, and then I go and change a number, the original number 1 is not impacted by that at all because they're separate. That is not true about reference types. If I have a little array here, and I take the array and I assign it to a new array, there are not two locations in memory. There is only one. So this data is referenced by numbers and more numbers. They are looking at the same memory location. That means if I change any of these numbers, that change is going to be picked up by numbers and also by more numbers. So in a situation like this, okay, where I have a numbers array and I set more numbers equal to numbers, if I use more numbers to change the values, I am changing the values in both arrays because there is only one set of numbers. Okay, and that is what this example shows. Okay, so even though I was accessing more numbers here, you can see that the number array was impacted. Okay, because there is only one. Okay, so that is really important to remember. Boxing and unboxing. So this basically deals with converting a value type into a reference type. That's what boxing is. And unboxing is doing the reverse. you convert a reference type into a value type. And this is actually converting. This is not using, the ref keyword or the out keyword, okay, that we reviewed last week. This is actually doing a conversion and changing the value. So how do you box something? Here's our value. Okay, so this is a value type. And then if I wanted to box it, I would create an object, okay, calling it number object, and I would assign number object the value of number. Okay, and because I'm putting number, which is a value type, into an object, it now becomes an object, and I have boxed it. Okay, and one thing that you should note is that when I do this, number and number object are still separate. They're looking at different places in memory. So number is looking at the stack. Number object is looking at the heap. So I can make changes to number object. It's not going to affect number because they're looking at two different places in memory. Okay, and so this little example kind of shows you that changes to one don't affect the other one. Unboxing is if you take a reference type and you convert it into a value type. And this is achieved using a typecast. Okay, so I've got my value type here. And then I've got my object. Okay, and then if I wanted to unbox the object, all I have to do is put a typecast int in front of it and store it in an integer. So what is the end result if I did this? I would have number 1 with a value of 10, number 2 with a value of 10, two different memory locations in the stack. And then I would have number object with a value of 10, and that value would be stored in the heap. So I'd actually have 3 number 10s being stored. Okay, and then I can make changes to any of them, and they will not impact the other one. They are totally separate. So why does boxing and unboxing matter? You have to pay attention to the type of data you are working with, because when you pass the data to methods, the data is passed differently. If it is a value type, a copy is passed. If it is a reference type, you are passing the real thing. Any modifications that you make, you are changing the real data. Okay, there is no copy, there is just the real thing. Okay, so that is why it matters. Okay, and so we talked about this in the review, and you guys also did an assignment that dealt with this. So I'm not going to talk about it again. You can read through it. And if you do have any questions, please let me know. But this is the same information that we had in the review.